Welcome to another day on the Journey Shake Chem. I'm so excited to see you here today. Please do the 2 warm-up questions to the best of your ability in your composition notebook, and I'll explain them in a moment. The question in number 1 can be very challenging, but I know that you're up to the challenge. We need to have 3 things in front of us: the periodic chart, the penguin sheet, our notes with the 5 types of reactions. In number 1, I see that I have an acid anhydride. I know that this is an acid anhydride because it's 2 elements and one of the elements is oxygen. Therefore, it is an anhydride. Then I look at the other element. Phosphorus is a nonmetal. Therefore, it is an acid anhydride. Now, oxygen has a charge of -2, and there are 5 of them, which gives me a -10. There are 2 phosphorus, and compounds are 0. Therefore, in this case, phosphorus has a +5 charge. Now, in acid anhydrides, it is extremely important for me to determine the oxidation number of the anhydride, because that will determine which one of the polyatomic ions that I will need to write. Phosphorus, we determined here, this nonmetal is +5. We only have 2 possible polyatomic ions that have phosphorus in them: phosphate and phosphite. Now, in phosphate, oxygen is -2. There are 4 of them. That gives me a -8. This polyatomic ion has an overall charge of -3, and therefore phosphorus is +5 in phosphate, and that is the one that we want. However, we might as well just practice and do the phosphite. Oxygen is -2. There are 3 of them. That gives me a -6. This polyatomic ion has a -3 charge, and therefore phosphorus in this case is +3. However, we want the phosphate. And I know that an acid anhydride plus water will give me an acid, and acids always start with hydrogen except for water. So I start with hydrogen, and I determined that it was phosphate. Now, we know that phosphate has a -3 charge, and hydrogen is +1, and compounds must be 0, and therefore hydrogen, I need 3 of them, because +3 and -3 is equal to 0, and that's the formula for phosphoric acid. Now, phosphoric acid and sulfuric acid are exceptions to our naming rule, and they start phosphoric acid with 4 oxygens, and normally that's 3 oxygens. So that is an exception to the rule. In B, and also in A, I should note if I form an acid, my solution is going to be acidic. That's pretty straightforward. Now in B, we have a base anhydride plus an acid anhydride, a metal with oxygen and a non-metal with oxygen. And whenever we have an acid anhydride, we must determine the charge of that non-metal. Oxygen is -2. There are 3 of them. Therefore, we get -6. Compounds are 0. There are 2 bromines. Each bromine is +3. Then I must look at my polyatomic ion sheet. And bromate, perbromate, bromate, bromite, and hypobromite are my 4 possible polyatomic ions. I need to find the one where bromine is +3. Oxygen is -2. There are 4 of them, which gives me a -8. And this polyatomic ion has an overall charge of -1. In this case, bromine is +7. That's not the one I'm looking for. Oxygen in bromate is -2. There are 3 of them. That gives me a -6. this polyatomic ion, as all the polyatomic ions on the penguin sheet are -1. And in this case, bromine is +5. That's not the one I want either. Now in this compound, oxygen is also -2. There are 2 of them. That gives me a -4. The polyatomic ion's overall charge is -1. And in this case, bromine is +3. Bingo! That's the one I want. Bromate is the one I'm looking for. Now, when I have a base anhydride plus an acid anhydride, I get a salt. And I need a salt to be a metal with a polyatomic ion because I have all of these oxygens. A salt is my metal, and my polyatomic ion that I determined had the correct charge for bromine. Now, I understand that there are 2 lithiums here, and I'm not concerned with you determining and balancing this. I just want you to get the correct formula for this compound. That's enough of a challenge for now. And in order to determine what kind of a solution that will form, I have to go one more step. This is very much like the lab. We had all kinds of salts, and we had to add water to it. So I'm going to add water. Now you'll recall that we add water as HOH because it separates as hydrogen ions and hydroxide ions. The hydroxide ions will form the base and the hydrogen ions will form the acid. They do the do-si-do. And therefore I am going to get lithium hydroxide and bromous acid. In order to determine which type of solution we have, I have to look at these compounds. Well, lithium hydroxide is one of my strong bases. And bromous acid is a weak acid. It is not one of the 7 strong acids. And we know that the strong rules, and therefore my resulting solution will be basic in this case. I know it's an extra step, but we can do that. We had all that practice in the lab. I'm sure you're good at that. You can determine what the resulting solution is by finding the parent base and the parent acid of this salt. The last one is your acid plus your base. We know they do the do-si-do. An acid plus a base gives me a salt plus water. The hydrogen and the hydroxide combine to give me the water. The salt is the metal with the polyatomic ion. And in this case, I don't need to worry about the charge because the polyatomic ion remains the same. There's no change. It is just calcium chlorite. However, I still must balance the charges in the compound. And calcium is +2 and chlorite is -1. Compounds must be 0, so I need 2 chlorides. To determine what the resulting solution is, I see that my chlorous acid is weak and my calcium hydroxide is strong. So we remember that the strong rules, and therefore my solution will be basic. And that's how you do number 1. And will be basic. And that's how you In number 2, we are determining if these compounds are a weak, strong, or non-electrolytes. It's very important to realize that there are only 3 categories of electrolytes. They are either acids, bases, or salts. And the penguin sheet will tell you which ones are strong. There are only 7 strong acids. If it's an acid and it's not one of those 7, then it is a weak acid and a weak electrolyte. Again, I am going to be giving you names often for the remainder of the year. I am going to write this formula out, and you should also be able to write the formula. Notice that it begins with hydrogen, therefore it is an acid. The question I ask myself is it one of the 7 strong acids? The answer is no, it is not. Therefore, it is a weak electrolyte and it is a weak acid. Chlorine, 2 2 oxide is telling me chlorine has a +1 charge. Oxygen is -2. The lowest common multiple is 2. Therefore, I need 2 chlorines. Now, notice that it is a compound that is composed of 2 different elements. Oxygen is one of those elements. This is an acid anhydride, a nonmetal with oxygen. And all anhydrides are non-electrolytes because they're not acids, they're not bases, and they are not salts. Therefore, they are non-electrolytes. In the case of C, I'm given a Roman numeral here, so that means that iron is +2. Acetate is -1. Fe parentheses C2H3O2 twice because compounds must be 0. This is a salt, and therefore it is a strong electrolyte because all salts are strong electrolytes except for the mercury salts, and iron is not mercury. Therefore, it is a strong electrolyte. In this case, tin is +4. Hydroxide is -1. And therefore, I need 4 hydroxides to get to 0. +4 and -4 is 0. This is a metal with hydroxide. Therefore, it is a base. It is not one of my strong bases. That would be group 1A and 2A with hydroxide except for beryllium. And of course, hydrogen is a nonmetal, so that would not even be a factor. This is a weak electrolyte. It is a weak base. It is a weak electrolyte. Now, don't forget, you have to complete writing up that report on the lab that we did on hydrolysis. You might consider doing question number 1 in the conclusions first because that will tell you what the parent acid and the parent base are in order for you to fill those in the data table that you made up. That's just an idea that you might want to do. You have to do both sides of the worksheet tonight, and you have an assessment coming up next week, so I wish you all the best in that. I know you'll work hard, and I can't wait to see you tomorrow.